So yeah, welcome to the future. Andy and I were sitting next to each other in Luke's keynote saying, wait, he covered everything we were going to talk. What's left? So this will be a bit of a survey of the future. We'll go a little deeper than Luke did in his talk, but we will be talking about some of the goals for the future. Some of the goals for the future, to reiterate, are make your backend servers easier to scale, so and easier to work with operationally. Make the client code, like system software, lightweight, low footprint, very fast, and make it possible to write the code for your infrastructure in beautiful, easy to maintain language.
Yeah.
So all those things.
And since we're saying it was a little bit covered in Luke's keynote, and this is a bit of a survey, please feel free to ask questions.
Yeah.
We can kind of see the audience, so. Move on.
Does this work?
Yeah.
Yeah, so quick intro slides. I'm Kylo. I joined Puppet last summer in June, and I mostly focus client side, which means so what Puppet Agent does, also Puppet Resource, if you're familiar with that, and then Factor and Native Factor. That's all the stuff that I more or less focus on.
And I'm Andy. I've been there since about March 2012. I'm on what we call the platform team, mainly focused on server side. And actually, one of the things you saw from Luke's keynote, our server is changing quite a bit. And actually, my team itself is now much more just the language. That is really our current focus. So we're going to be covering a bit about the server as well.
So we're going with a bike theme in this talk. So this is France. Probably knew that. So we just copped the Tour de France image from one of their routes from a couple years ago, but this is going to be a tour de Puppet. We're going to go in, there's going to be 4 rough sections to the talk. We're going to talk about release cadence first, then some of the changes that are already in place in, or that will be in place in Puppet 4.0. And then third, some of the work we want to do to componentize Puppet, which currently is kind of a large entangled code base. And then last, we'll get to Native Factor.
One of the things to know, we really tried to take the bike theme through the whole talk, and we learned how far you can take a metaphor before it breaks.
Yes.
So originally, our sections were labeled things like forming the peloton, cruising through the flats, climbing the hills, and then doing the lead-out train. But yeah, that was a little obscure and a little hard to actually make work. But cadence does work.
Cadence does work, yeah.
You want me to take this?
Yeah.
All right. So cadence. So we've been releasing Puppet as a whole on about a 3-month cadence. That cadence has been pretty good. We've been doing it from about September 2012 is when we did Puppet 3.0. And around December 2014 is where we want to get Puppet 4.0 out. So that's quite a long time. That's a release cadence where every 3 months we had a new feature release about. Every few weeks we had a bug fix release. And actually, if you want to count them up, actually I think I took these numbers a little while ago, so it's changed slightly since then. But we've done 21 releases in 24 months. And 14 of those were bug fix releases. 2 of those were feature releases. And a bunch of them, and 8 of those were feature releases, and 2 of those were actually dead on arrival. So we screw up sometimes on those releases. I'm really sorry. Puppet 3.5.0 was not the greatest. And apparently 3.2.0 was also dead on arrival. So we've been doing that for a while. The release cadence, though, has been, you could say, somewhat consistent, but it's also kind of long. We get patches from people, and we get new features and that kind of thing implemented. And sometimes it takes several months before they'll actually be able to see it. And what we actually rather have is that you can get to your changes, get to your new features much, much sooner. So right now we're hovering it around. You can kind of look at the graph. We're right around 90 days to 100 days between our major release, our feature releases. 3.6.0 was the outlier. We discovered that, what was that, about 40 days? 40 days was a little too short for us. But it also showed us that we could do it if we needed to. We could actually release at that cycle if that was what was needed to get new things out there and working. Actually, Gene Kim was talking about how fast you can turn around, and we've actually got our cadence down pretty well so that if we make a decision to do a release, within a week we can have it all ready together and good to go, which is not the fastest thing, but considering the number of components and tests that we have to run, it works out pretty well. However, oh, do you want to go back?
Oh, actually, the other thing I was going to say on that slide is, in addition to our releases being at roughly 90 days, and we'd like to tighten that up some. Also, the whole 3.x lifetime was 2.5 years, or 2 years and change, and or it will be when we release 4.0 in December, I should say. I'm projecting forward. But we'd like to both shorten sort of the height of this graph in the 4.x series so that the feature releases maybe aren't 3 months spaced apart, but maybe 2 months spaced apart. We don't want to spin people's heads, but we want to be able to get code out faster. We'd also like to shorten the width of this graph so that the total lifetime of, say, the Puppet 4 major is on the order of a year rather than on the order of 2.5 years.
And that's not to say that every year we're going to break the world. It's every year there's going to be something that we'll want to release that is a technically backwards incompatible change. We need to make sure that it's up to us to make sure that we're actually putting out the information so that you can make the decision about whether or not that breakage affects you or not. It's not that we want to make your life really hard with more major releases.
Yeah, so and part of the motivation for being able to move those majors a little faster is that this is sort of my image of how the core Puppet software is designed today. And it's really, for those of you who've been in the Puppet core software, it's a thing of beauty. It's really, it's really amazing. There's some awesome, super powerful abstractions in there. But it's also very, very delicately held together. And a lot of times adding a feature or even fixing a bug sometimes requires an incredible balancing act to pull it off. And that means we aren't able to always move as quickly as we'd like in terms of fixing bugs or adding features. So what can happen when we want to make one small change is it goes like this. And
remember those dead on arrival releases?
Yeah, exactly. That's sort of what happened with 3.5.0 and directory environments. There's just so many parts to keep balance that it can be a challenge. So that's part of why we want to move to faster majors, is so that we can toss some of the old code that's making it difficult for us to add the features that people are actually asking for.
And actually, I think this image is also really good because it covers how we're going to be approaching this as well. Because when you've got these big monolithic systems where everything's interconnected and hard to pull apart, the way that you actually want to start tackling it is you want to start pulling them apart and coming up with very clear separations between the pieces, coming up with very clear responsibilities, and then you can actually reason about it much better. And so even though, yes, sometimes it falls apart and everything comes springing out, in some ways that's what you want to do, but in a controlled fashion. Everything comes falling out of it. So how are we going to do this? Actually, the way we're going to do this is not too far off from the way we have been doing it already. You've seen it with the experimental features that we had in the 3 series. That was, we're creating new components that you can turn on, that they kind of switch themselves into the larger system, and you can try them out. We're going to continue doing feature flags. We're going to continue doing semver to make sure that we're very clear about what it is that we're trying to achieve with any given release. Are we just trying to add new features? Are we trying to fix a bug? Are we doing a major change that's going to break some things but move us forward? And I'd also like to talk a little bit about what these experimental features are and what makes them experimental. The experimental nature of them is we can only test so much. Kind of as Gene was saying, if we try to test even more, it actually puts us at a higher risk. So we just need to get it out there, and we need feedback on how is it working, how well is it fitting in, is it actually solving the problem. And so the feature flags and these experimental features are where it's not certain what the right solution is and whether or not we've actually achieved it. So that's why they're there. That's where we get the feedback. And kind of we want to keep going in that direction because so far it's actually worked out pretty well. There has been unfortunate side effects every once in a while. Sorry about that. There's been a large number of deprecation warnings as we learned that the experiments were correct and we had to move things forward. And that's telling you that's how it's going to start moving. So moving on, do you want to say anything about this? Or should
No,
we
keep going.
keep going? All right. So let's start talking about some of these changes that have built up over time. And so the world does change. Things move on. And so coming up in Puppet 4, hopefully, if you've been keeping on top of what we have been doing, none of this is a surprise. If you haven't been keeping up, well, there's some places you can go to figure out a bit more about it. So for instance, the language is being changed. Luke talked about this in the keynote. Henrik Lindberg is going to be going over it in his talk in much more depth than I'm going to try here. And that's at what, 3:30? 3:10, right here. And so we've also made some changes to how environments work. And then there's just a general cleanup. So how's the language changing? Well, one of the ways the language is changing is we're adding a few features. One of them that you saw in Luke's keynote is that thing at the very top there, array of string. You can now actually start talking about types. And it's amazing once you can do this how often you find that the system was actually not doing quite what you wanted because the data flowing through wasn't what you expected. And so once you can start actually adding these kinds of annotations to the system, actually, how many people write all sorts of validate and is function calls in their modules to try to figure out, is this data safe to move on to the next piece? Yeah. And if you're not doing that, you should probably do more of it. And so what this is this can't cover everything, but it can cover a huge amount of that and make it much more just integral to the system. And it can also help you in documenting. Because now anyone can look at this and they can say, oh, that's expected to be an array, not just a single thing. Well, that's interesting. OK, and you didn't have to say that. It just says it itself. The other thing we did is, as much as it pains us to admit, Puppet is not entirely a declarative language. You have to actually transform data sometimes. And for that, you need some more powerful features in the language. So I gave one example here. There's actually several more things that use the same mechanism. But we now have iteration in the language. So you're going to get in your data from Hyra or some other data source, and you need to transform that into resources. So for instance, here, I've got my define that takes an array of strings. It's going to iterate across that array and create a notify resource for each one. Pretty powerful system. There's a lot more to it, and Henrik can go into that. The other thing that we did was we needed so I'll give you a little background of where this one came from, directory environments. You're probably now getting deprecation warnings if you've updated to some of the more recent releases where we say module path is going away, manifest is going away, and what it's going to is directory environments. And one way to think about this is that we're bringing environments much closer to being like modules. Because if you think about it, an environment really is a lot like a module. It's got a very similar structure. It's got a set of modules. It's got a set of dependencies on its modules. It's got a set of manifests. And it's got a name. And there's more that we could add to it. So directory environments actually was solving a completely different case, but brought it together into this much nicer whole. And the case that we needed to solve was, what environments does the master have? Under the current system, there was no way for us to answer that. So we decided, well, how about if we just have something that you have to enumerate your environments out? And then that led to this structure, and it had this amazing similarity, and now we've started thinking about it in that manner. So directory environments is one of those new features that's coming up. It's had a bit of work done on it. It's another one of these things where our release cadence was very useful. We put it out initially in 3.5.0 and broke everything. We called back 3.5.0. We fixed it in 3.5.1. We tweaked it again in 3.6, and we tweaked it yet again in 3.7 based on how people were using it and what they were finding they needed that we had forgotten. So,
I know the thing's beeping like crazy.
Yeah, it's kind of annoying to have. There's a little cue thing down here beeping about slide changes that I'm not doing. And then we've just got general spring cleaning. There's the many, many, many deprecation warnings of things that have changed over time. I'm really sorry about the number of them, but this is why we also want to take that major cycle a little shorter, because we don't want to build up as many. But we've got a huge number of these spring cleaning things coming about. Some of them are purely internal that hopefully you'd never actually see, but they were there because it was technically a public API, and someone could have written something against it. And so we're going to be getting rid of that. Other things are to finally really get rid of some things that were a little bit questionable in the system, such as sending YAML across the network. If you want to have an interesting conversation about that, talk to me. I'll tell you all about it. We're getting rid of the using active record store configs. PuppetDB has really proven itself to work really well. And it's really our future for how store configs can work. So we're going to get rid of kind of the old one that's been sitting in there for so long. Various other things.
Ruby 187?
Ruby 187 support.
Ruby 187 support.
We have to move forward. And so right now we're trying to figure out what does it mean? How do we get rid of Ruby 187 but not cut off everyone who's on systems that only had Ruby 187? So we're working through that right now. But that's kind of some of the spring cleaning that we're doing, was just cutting off some of the old dead wood, moving us forward, getting us ready for our next stage of sprinting to the line.
Yeah, I was very excited last night. I went and looked at the diff, and Puppet 4 at this point has added 2,000 lines of code and removed 8,000 lines of code.
And we haven't even started.
And we really barely started with all the stuff we're going to throw out. So, and that translates to like faster test runs, easier to maintain code, quicker iteration on, again, the features people want. So that's going to be a huge win.
And hopefully and ideally, most of these things that we're deleting, you actually wouldn't even notice, because they were features that were for some reason in there and they've been superseded by something else, or they were never used in the first place. Sometimes things get into sometimes we put in features and it turns out they were never used. So I'm going to talk a little bit about how the server now is going to move forward. And Luke's keynote really touched on it, which was we're going to be breaking up into more components. So as I said early on, really the way that we can do this is just start splitting up the system. There's microservices is a really big topic right now. There's a reason for that. It's really nice to have that kind of separation between everything. There is actually a downside to it as well, and I'll talk about that. And our system does not completely forget that there is that downside. So the downside is that now you've got a lot more services you have to maintain. And ideally, Puppet should not be the thing that you're spending all of your time maintaining. So what we're actually working on is making it so that we've got a lot of different services, but they can all run together inside a single process. So that means that the system can be split up in that way if it's needed, but it can also be deployed into a single process so that when you don't need all of that extra scaling, it's not the maintenance burden that it could be if it was 100 individual processes trying to talk to each other. So we're going to be splitting up Puppet into a lot of these different components. And one of those first components that you just learned about this morning is the Puppet server, which for a long time internally we were calling the JVM master. And what that is we're dropping Passenger and we're dropping Apache. We're dropping that kind of whole stack around MRI. And we're going to switch it over to be using JRuby. And we're going to be switching it over to using the JVM. And we're going to be using the same technology that PuppetDB uses to run as a web server and be very low maintenance and have a lot of data about how it's running and what it's doing. And so that's where that's going to be going. This gives us an incredible amount of control over how Puppet is actually going to be running. And it takes away a bit of control from the user, but hopefully not in manners that actually are really all that important, because it allows us to do things that a lot of that control was used to achieve before. So one of the things that we're looking forward to with this new technology is that we'll be able to do what's actually true environment separation. Right now, if you use environments and you have custom types and providers and you have custom functions, you probably have encountered these really strange errors where sometimes it just doesn't quite do what you think it should ever do, and then the next run it works just fine. And what's going on there is that when we're running under MRI Ruby, which is the Ruby written in C, the one you usually use from the command line, when we're running in that in Passenger, we can't make a distinction between what environment what code came from. On the JVM, using JRuby, we can actually do that. And so your environments can actually truly be separated from each other. They can run independently. They can have completely different Ruby code as their extensions, and they won't interfere. So that's actually something that's now open to us. Now, there were all sorts of hacks that people came up with when using Passenger to try to achieve the same thing. But now we can actually do it, and you don't have to. So the next thing that we're working on right now is, I called it Stringified. There's the Puppet doc command, which has always had a bit of a checkered history. Never quite works as you might expect. And unfortunately, with the new language, it doesn't work with the new language at all. It can't parse the new manifests. So what we're working on right now is a replacement for that. And once again, in this kind of mode of let's split it up into smaller components, it's published up on our GitHub repos right now as Puppet Lab strings. We're calling it strings. It's based on the Yard markup format, and it can. We're working on its 0.1 release at the moment. Hopefully, by the time 4.0 comes out, it'll be 0.2 or something like that. It'll be something that you can use, get you going, keep you moving, and much, much easier to use. So we're working through that. We're actually looking for a lot of feedback on that one for how can we make it better. Is this actually the kind of documentation you want, or should we go to a completely different way of doing it? And then we are planning a whole bunch of other upgrades that are going to be going on kind of as the experimental features during the 4 series. And this is all, as I said, I'm the language person, so this is all the language stuff and things around that. We're going to be revamping the catalog. There's a lot of stuff people want to be able to do with Puppet that we can't express right now in the Puppet catalog. One of those things is some sort of way of getting data between the nodes or delaying what data is going to be in there, having duplicate resources. Having it so that 2 different manifests can say the same resource, and as long as they're not in conflict, we can do it. So we're going to be working on that. That's what we call our new catalog or revamped catalog. You'll also hear us talk about that as the new catalog builder. There's going to be further language changes all around that, because as that starts happening, it changes the way you have to think a little bit about what a resource is, what it means to declare a resource and put it into the catalog. And then we're also trying to figure out what orchestration means. How does orchestration fit into Puppet? Where can we build it in better? Where does it actually work out? What can we change? What can we build on top of it? At this point, unless there's any questions right now. There's one right there.
So one way I've managed to break catalogs is putting things like gzip files using the file function, because destroying
Right.
a server with like 10,000 file resources. So we started using the file function to stuff it into the catalog, and that works great until you put binary data in there, and then the parser explodes.
Right. So the question was, one of the things they do right now is they use the file function to load binary data, maybe gzipped files, and they throw them in as the content parameter for a file resource, which is great because it reduces the number of requests that the agent will end up doing to the master, but also horrible because it ends up blowing up. Because it's binary data. And yeah, so that's actually a problem we've been trying to figure out. There's a couple ways we could address it. We don't have a solution at the moment. One thing we do have is that in 3.7, we made a change where the agent will reuse its connection to the master. It'll do some connection pooling. So if a lot of the overhead was just setting up that SSL connection every time, which is, I can't remember, it's something like 8 round trips just to get an SSL handshake done, that should be reduced significantly. The binary data question has been a big one on our minds of how do we deal with that. And we don't have a good solution at the moment. But yeah. Anything else? Or Kylo? Let's move on to you.
So as Luke mentioned, we have a new implementation of Factor in the works. Does everybody know what Factor is? So we have a new implementation of Factor in the works. The project's called C Factor. It's actually implemented in C++ 11. And we've done that for a few reasons. 3 basic reasons. One is performance. It's just so much faster. Ruby is a wonderful language to write in. It's not fast. That's an understatement. So one is just performance. We want to make, as Luke mentioned in the keynote, we want to make the client code fast, low footprint, et cetera. The other reason is portability. Classically, Puppet runs on servers and data centers, but increasingly people are wanting to deploy it on switches or in very resource-constrained containers and whatnot. And so reducing the footprint really helps with portability as well. And the third is the third appeal to re-implementing is frankly going back to the tech debt theme that's come up a couple times. We can just walk away from some of that tech debt and re-implement stuff in a fresh, sane way. So that means right now we have sort of two parallel implementations of Factor. We have the Ruby Factor running through. So Ruby Factor, we just released 2.2 last month with a bunch of structured facts. Native Factor is being implemented in parallel alongside of it and has got fact parity for Linux and OS 10. We're working on Solaris and Windows, and actually we're starting to add newer facts in the native Factor only. And then we plan to you can play with that today, but we're planning to flip that switch in Factor 3. So Factor 3 will have a native Factor back into it. So. So a couple things. So I have a quick performance slide. There's not that much to show for Factor. Excuse me? Oh yeah, let me talk about that. So
Repeat the question.
So yeah, the question was how is implementing in C++11 going to affect custom facts? So the native Factor implementation supports custom facts. The way it does it is I'll give you the TLDR and I can deep dive if you want, but if it knows it's already running in Ruby, then it uses that Ruby and implements to the Ruby C API to emulate all the Factor API functions that custom facts use. If it's running standalone, which i.e. outside of Puppet, then it just looks for a Ruby and so uses your system Ruby to run custom facts. That's something you're more likely to do just in a debug development environment, but it's still handy to have that ability. So it supports custom facts, and it supports, and then it also supports external facts. And we're also hoping to, one thing we get with a lot of the extension points in the Puppet ecosystem is people who want to be able to implement in languages other than Ruby. So external facts are a step in that direction, but at this point they're less featured than custom facts. For example, you can't access the built-in facts currently with external facts. This is not yet implemented, but what we're toying with doing for that, and we'd love feedback on, is to provide all the built-in facts as a JSON blob on standard in for external facts, and that would allow you to write external facts in Ruby if you wanted, or in Python, or anything that could parse a JSON blob. So, long answer. Does that answer the question though? So Factor is so native Factor is quite a bit faster than Ruby Factor.
Question.
Oh, sorry. I'm completely blinded up here, so it's hard to see. Yeah, shoot.
Does that mean that in C Factor you also expose a public C API with bindings?
Yeah, there is a C API. We've been debating whether. We're curious to know if people will want to use that. There's an API that the internal resolvers that we're implementing in C++ use, obviously, and that's all public currently. But we would love to get feedback on whether that's of interest. You can definitely write faster custom facts that way. Certainly, if you're interacting with services that have C APIs, you can just bypass a shelling out experience. But it's also a little more work, so.
No, just wondering also if maybe other projects, other configuration management tools could blend it in with bindings, for example.
Repeat?
If other configuration management tools could use this with bindings to implement this functionality as well.
Oh, yeah. The question was whether other configuration management tools could use the C API with bindings. So actually, currently the API is actually, I misspoke, it's a C++ API, not a C API. We could extern it to a simple C API, and the point being that a C++ API is harder to come up with platform agnostic bindings for, but we could actually external as a C API as well if that was of interest. Other questions?
Maybe one last one.
Yeah, shoot.
We're a Python shop, so you're talking about bindings. Would that mean that we'd actually be able to either write ourselves or get from you Python bindings so that we could write custom facts in Python rather than Ruby?
Yeah, we haven't decided if we would want to provide Python bindings or just say, look, here's the interface we're going to work with for external facts. Knock yourself out, work in whatever language you want.
If you're not familiar with external facts are where Factor will execute another program and just read its standard out to get the information. So yeah, that allows pretty much anything to be done. 9 minutes.
Okay, 9 minutes. Anyway, C Factor is faster than native Factor. I actually tried, for this slide, I spun up a bunch of different VMs, and because I didn't want to overstate speed improvements, and this is actually the slowest improvement I was able to find. And even in this case, this was a Fedora 20 VM running in Vagrant on my laptop. Anyway, in this case, it was 3x the speed, 800 milliseconds for Factor, 250 milliseconds for C Factor. So it's comfortably faster, and that's as little speed up as I've seen. So it's got a lot of potential to speed up fact collection. And of course, I mean, there's pathological things you could do. If you have an external fact that goes and blocks for an hour on some external service, it's going to take an hour, and you're not going to care about 600 milliseconds. But you've also got other problems to solve in that case. But a lot of potential to speed things up. Portability, already spoke about that some. I mean, basically GCC, GCC can be built for pretty much anything. We are requiring a newer GCC since we were starting a fresh C++ project. We wanted to start with a current version of GCC, but it's going to be a real win for getting Puppet basically more ubiquitous, getting Factor, and then eventually Puppet just more ubiquitous, in that it will be able to run on, again, containers, switches, storage devices, anywhere where we can run GCC.
It also starts to address, I've sometimes heard people say that they can't run Puppet agents simply because Puppet would take too many resources. And one of these shifts of moving to the native code, Puppet would use a lot fewer resources, CPU resources, memory resources, whatever. And so get rid of that kind of question of, is it even possible to have Puppet on possibly even a large machine, depending on how much it has to do for other things.
Yeah, absolutely. When I was first spiking C Factor, I was comparing the fact output of C Factor and Ruby Factor, and for some reason the memory facts were way off, and I thought my math has got to be completely wrong. I don't understand how it could be, screwing up this math. Well, it's just the Ruby MRI chews up a lot more memory. So, when C Factor is running, there is more free memory on the system. So one question I get with native Factor is, well, that's just Factor. What about agent? So we, by the way, this is Danny McCaskill, who's a trials writer, and this is him riding around in San Francisco. So it seemed kind of appropriate. So native Factor, Factor is in some ways sort of the easy part of converting to native tooling. In that it does a pretty straightforward job that I think is kind of easily understood, and its extension points, current existing extension points, are pretty modest, and that's that is purposefully why we started with Factor, rewriting Factor to native Factor, as opposed to diving in to try and rewrite all of Puppet first blush, which would be a bunch more work, and also starting with native Factor has allowed us to sort out some of the toolchain issues. So we're now building toolchains to build native Factor for Linux and Solaris and Windows. And so we're getting some of our kind of release engineering toolchain all ironed out with a more restricted set of problems to solve. But where we want to go next is we want to get to Puppet Agent being native as well. and Puppet resource. And again, this is the goal here is that Puppet client software becomes just like system software. It's inobtrusive, fast, stays out of the way. Think about NTPD or something. You'd be shocked if NTPD were consuming a sizable percent of your CPU and memory. And we'd like to move Puppet Agent in that direction to being lightweight, low footprint, responsive. So soon we will be taking the plunge into native agent.
So let's start the bike shedding. Any questions? Comments?
I have a question about masterless Puppet. Is PuppetFly still going to be supported? Am I going to need a JVM to do it?
Yeah, the
That's a good
Puppet
question.
apply question. With the server moving on to the JVM, written enclosure, what's going to happen to Puppet apply? That is a very interesting question and something I'm still arguing with myself about. There's a couple ways we can answer that. I don't know how much detail I should go into just because of time. But let me try to give a couple possibilities. So one possibility is what Puppet apply really needs is it needs to have the language implementation available to it. It needs to be able to produce a catalog, and then the agent side, because Puppet apply is really just produce a catalog, apply a catalog. The agent side is going to native, so that's not an issue. It's all, how is the language implemented? So the language, we have a couple choices. The language, we could say, yeah, you need a JVM, because you're saying you want all of Puppet, all of the ecosystem on a single machine. So we could just take that path and say you need the JVM. The other path we could say is, well, let's re-envision what Puppet apply is. Puppet apply could also be viewed as you want to do a request to another system from here, where this is where the manifests live, and you want to ship the manifests over somewhere else, get them to run, and have the result come back. That could be another way of viewing what Puppet apply is. It's more of like it's local control, not necessarily local computation. Another way we could approach it is we could say, well, actually the language itself has to be ubiquitous too, which might drive us to write that in C++. So the language implementation would move to C++. And that would have some nice advantages. Speed would be one of them. It would also have some disadvantages because actually getting it to run on the JVM, just like JRuby gets incredible advantages from running on the JVM, because every time the Java ecosystem makes a stride forward in optimization or memory utilization, they get it as well. So leaving the JVM would kind of be sad making because we wouldn't get that anymore. So about all I can say is I've been thinking about it and I'm welcoming input.
I think we have another question over here.
So kind of related to that question, it seems like the conversation is that you guys are moving the closure at least to the front end of the new server. There's this talk of you're using JRuby and some memorandums. There's obviously still Ruby stuff somewhere in there. How deep does the closure versus Ruby seem to be going with the server side?
So it's the question is, on the server side, there's been this very obvious, we're moving to closure, but there's also JRuby and there's the Ruby. How deep is the Ruby going to go? So essentially our future direction, I think, is going to be that things that have to be everywhere are going to be in C++. Things that can be centralized onto certain systems, those can be on the JVM, ideally written in Clojure. And the thing is Ruby is not going to be going away. Ruby is still kind of our scripting language. I think there's going to be a lot of points where Ruby is actually kind of the extension language, but we'll be creating extension points for other things. You're now hearing me kind of talk about what I think it is, but I can always be overridden on certain things. So Clojure, yeah, Ruby's not going away. Ruby will still be there, probably being used for glue, definitely used for extensions. We don't want to drop all of the custom functions that have been written, all the custom extensions that have been written. So Ruby will be around for at least a very long time.
Last question.
Last question, all right. Oh, let's try over there, sorry.
Any change for Puppet device?
Any change for Puppet device? Yeah, I'll let you take that.
Well, if I look some, there's no currently planned changes for Puppet device. There's no currently planned changes for Puppet device, but I'd like to have conversations about. I mean, Puppet device is it's both really powerful and it can be kind of awkward to use, and we'd like to have conversations about what what sort of the ideal model is for solving the problem that Puppet device solves. But we're not, no current plans to change anything about it.
All right.
We are 6 seconds to go.
Oh well.
Taking 6 seconds away.
All right. If you can go ahead and thank Kylo and Andy.
And thank you.
Thank you. Yep.
All,